This conference will now be recorded.
Good morning, everyone, and good evening as per your time zone. So, yesterday we went over the demo session of the course, the what we're going to cover, and things like that. And from today, we're going to start from the main course that we have, that's Cloud Performance Engine in DevOps, and we'll be starting with cloud computing. Before that, I would just like to just recap what are we going to cover and how are we going to plan this course journey. This is going to be 40 to 45 hours of course journey, and we'll be meeting every day, Monday to Friday, weekdays, 7:30 a.m. to 8:30 a.m. IST, and you can convert in other time zone as well, EST, MST. We'll be meeting daily for 1 hour. I think that's the best 1 hour. Giving 1 hour daily to the schedule will work out well. So I'm just going to go back to the course syllabus. I'm going to just recap things. How are we going to plan and how will we be progressing? And who are we addressing this course? Okay. So if you look at the course syllabus, I've given here clearly 40 to 45 hours of live training. So this is the last batch I have just concluded. It took about 42 classes, 42 sessions, so 42 hours, right? So this will be around this time for sure. And this you can consider 2 months from today. You can consider if it's August, you need to be mentally prepared that of September and October, you'll be packed. Till 15th of October, this course will go, and you'll be learning a lot. That's my promise from my end, but you need to commit yourself that till October 15th, you're gonna be with me and you're gonna show up daily on daily basis and you're gonna practice for whatever time you have in your day because we're just going to cover 1 hour. So if you devote an additional half an hour, at least half an hour, that should be good. Just to go over the record, and because you get the recording on the same day, you can just devote half an hour additional extra and just to recap what all we have done. That's all we need. That's all it's required to understand each and everything about this course. Okay. It's very much applicable. So who can enroll for this course? As I was mentioning this yesterday, anyone who would like to like performance testers or performance engineers, right? Want to move to the cloud space, the DevOps space, anyone who is a DevOps aspirant as well. Nowadays, DevOps and performance, like with a lot of overlapping activities that you need to perform. So if anyone looking forward to be in the cloud space, DevOps space, performance engineering, how do we work? How do we performance engineer the solutions in cloud space? This course is very much relevant for them. Anyone, developers or a support engineers who would like to switch to the cloud performance domain, cloud in general, cloud, I would say, because whatever we are going to talk about in this syllabus is going to be cloud based. If for everything we're gonna come to this AWS console and we're gonna practice and we're gonna see how things are being done, and that's the most important part of it because if you look at an AWS being the leader in the cloud space, we have 33% of market share. And in the interview, you'd be mostly asked questions on AWS, other than Azure. Second priority is Azure because again, Azure also covers around 20 to 22% of the market share. So if you just cover AWS and Azure together, basically you're going to cover 50% of the cloud's market share. And when I'm going to tell you about AWS, it's not like you will not be knowing about other cloud service provider as well. I'll be telling you what relevant service exists in other cloud service provider. Okay, because that's the key, right? That's the key. Because if I tell you that, if I just explain you, for example, this EC2 instance, one of the AWS services, EC2, Elastic Compute Cloud. If I just explain each and everything about EC2, to you, and I'm going to tell you that a similar service exists in Azure or GCP, you're gonna pick that up very quickly. And because it's the reality, every cloud service provider, the core functionality is the same, and the only thing what changes is the UI, the way it looks, and the naming. The naming conventions they adopt. That's what it changes. Underneath that, whatever we're gonna cover, it's the same. So it's not like, so you need to have at least one cloud service provider knowledge thorough, and that will be taking up AWS. And apart from that, I'm going to also tell you what relevant service exists in Azure or GCP. And if you are interested, you can have an Azure account of your own, a GCP account, and you can practice simultaneously, and you will understand that yes, it's the same. Core functionality is the same. So that's the approach we're gonna cover. Take AWS and deep dive thoroughly, and we can also talk about other cloud service provider. For example, if I just show you, if I say this particular screenshot, okay, if I have taken this image, here I have compared the other cloud service provider here. Okay, if you just at this image, okay, let me just do one thing. Let me download this image. Okay, I'm going to just zoom it and show you how things work in a multiple cloud. Okay, let me just I was talking about EC2 instance. EC2 is Elastic Compute Cloud. Okay, and that's the AWS thing. EC2, Elastic Compute Cloud. I hope you can see this. I'm circling here. In Azure, they call it virtual machines. It makes sense, right? EC2, what are we going to do? We are going to provision virtual machines only. And they are, Azure guys are not calling it EC2. The one I just showed you is EC2, right? I went to the EC2 instance, EC2 service. But if you open this in the Azure cloud, you're gonna find virtual machine name. That's all. And if you're gonna click on virtual machine, similar to EC2, the one I'm clicking, you're gonna get a similar kind of like a different UI, but the core functionality would be the same. And I'm gonna walk you over each and everything of this EC2. So you can easily relate to Azure and GCP. That's the idea. Okay. I just give you one of the example. In the Google GCP calls it compute engine. That's the only difference. They have it. In we have VPC. We call it for the networking. We call in AWS we call it VPC. If you could look at the last line here, the VPC, virtual private cloud, because that's the network of the default network of all the regions of the VPC. For this VPC, Azure calls it Azure Virtual Network. That's the name they have selected, they have adopted. You cannot help it. You just need to know, okay, what name Azure has adopted. So Azure Virtual Network, but the core functionality again is going to be the same. They're going to have 3 subnets. Everything will be the same. What we are covering in AWS. Okay, and then GCP is going to name that as Cloud Virtual Network. Fine, we cannot help it if they have adopted this. And if we work in GCP, if like let's say if you have a job requirement, we'll be covering AWS thoroughly here. And if you have a job requirement of Azure and GCP, you can learn in a week's time. You just need to know the relevant name, and that's what we're gonna do. Okay, that's how it works. We have RDS for relational database. In AWS, we call it RDS. Azure calls it Azure Relational Database, and GCP calls it Cloud SQL. That's fine. If they call it Cloud SQL, we have to just know about it. Okay, that's what they call it, but the underlying functionality is going to be the same. We call it EC2 calls it Elastic Load Balancing, ELB. Azure calls it load balancing for Azure. Fine, good. And GCP calls it Cloud Load Balancing. That's fine, totally fine. Just the name changes. Core functionality is again gonna be the same. So we're gonna talk about these things. Okay, we're gonna talk about more about AWS, but we're gonna just refer the other cloud service provider as well, like the way we did. Okay, and you're gonna practice on your own. If you are really interested to learn Azure and GCP as well parallelly, you can devote some additional 1 hour and you can learn. Okay, so it's your call, it's your interest. But we're gonna cover here. We cannot cover everything. All the cloud service provided. It's going to take additional. So our course will not go 40 to 45 hours. It will go for around 60 to 70 hours if we just go about talking about each and every service, relevant service in other cloud service provider as well. So we're going to focus on AWS. Okay, that will be the plan, and we're going to cover each and everything. Okay, so coming back to the syllabus. Okay, again, I was just going over that. Let me just walk you over again. So anyone, developers, support engineers who are looking to switch in the cloud space and the way how we work in cloud. See, for performance engineering activity or whatever activity, DevOps activity, we need to get comfortable with cloud first. That will be our intention. We need to be sure what are we doing in cloud, and then we can apply the relevant skill sets to get the work done. Okay, so we're gonna having that approach, we're going to take up each and every topic here. The course is very much applicable to the freshers. It can be very much applicable. So there's no freshers are going to get a lot of learning here because everyone talking about cloud. Experienced people are switching from on-prem to cloud, and if a fresher just get to uh, learn about cloud from the beginning, nothing like it. So it's the best thing. Okay, so again, coming to the course syllabus, that's the cloud computing syllabus topic that we're going to cover. We're going to cover each and everything from very scratch. Okay, so what is cloud computing? From very scratch, what do we mean by cloud? First of all, people do not understand. I do not, with a crisp knowledge, what is cloud? To make it simple, if you are working on-prem infrastructure, the infrastructure, the hardware that you own as part of your data center is on-prem. The infrastructure, the hardware, the resource which you do not own, which you take it for rent from other data center, from other cloud service provider data center like AWS, Azure, or GCP, that's cloud. Nothing can be simpler than that. This definition, you need to understand it's the same data center, it's the same hardware. The machine is not going to change, the VM is not going to change. From where we are taking it, from the way how we are consuming it is going to change. This is AWS console. I can have any number of servers. I do not need to own my data center. I do not need to set up my own data center. I don't have to go for land acquisition, construct infrastructure building. I don't have to put security guards. I don't have to put cooling mechanism for my data center. But eventually, I can get the thing what I needed in the first place. I can get the service. I can go to the EC2 instance. I can provision any number of servers. I can do anything. And I'm going to pay for this service to the cloud service provider. This happens to be AWS here, because I'm working in AWS. The similar thing goes for Azure and GCP, and there are other cloud service providers as well. You have IBM, you have Oracle. There are some other, so a lot more people are many AWS service cloud service provider options. So the end of it, I can provision any number of instances. Look at the server. If I just launch instance here, this is how I'm going to provision a server. I have the option of selecting any of these operating system. I can select Red Hat. I can select Amazon to Linux. I have all the flexibility. I can use Microsoft's Windows Server, because in the server, either it could be a Linux or Windows, right? I need to start with an operating system, and then I'm going to talk about how many vCPUs, how many CPU, how many RAM, how much disk I need. I have all the flexibility here without owning the data center, and that's cloud for you. That's simple definition in the cloud. That's cloud. There's nothing big. The infrastructure, the hardware, the resource which you do not own, which you own, it's on-prem. Which you do not own and which you take it for rent from someone else data center, like AWS. AWS has set up a data center. AWS has set up a data center in these regions. They have this region list. They have they have a lot many regions. Okay, they are into US East, North Virginia. They are US East, US West, uh, and you have Africa, Asia Pacific, Canada, Europe, uh, London, Middle East, South America. They have set up the data center. It's not like they don't have a data center. They have it. AWS has owns data center. They have set up a data center and they have the servers there. I'm just going to create my own server there. I'm going to leverage this management console. This is called AWS management console, their UI. And I'm going to create one server here. By default, I'm in a Frankfurt region, U Central 1. I'm sitting in Bangalore, sitting in India, remotely. I can create a server in Europe. How cool is that? I do not need to go to Europe. I do not have to talk to anyone there. But I can create a server in Europe. I can host my application in Europe. If I have a business requirement, if I need a web page, my application, my anything, I can create servers. I can deploy my application. I can have a flexible workload scaling mechanism in place. I can set up load balancer, auto scaling features. I can have Kubernetes set up, everything. I can have Route 53 for DNS. For domain name registration, we have this service called Route 53 here, like how we have GoDaddy and Google domains, where you can purchase the domain DNS. Here, AWS has Route 53. Okay. So for everything, they have this service, Route 53, they call it. Uh, so uh, being so connected remotely, I can create server in any part of the world, wherever they have the data center. That's cloud for you. So you can provision any server remotely over the internet. That's that's the power of cloud. And the startup organization, because they cannot afford to have a data center, they cannot, it's very costly thing to set up a data center. They can use this cloud service provider, they can create servers and they can have their application up and running, and they're going to focus more on the development part of it. They're not going to think about how can they host their application. They can host in any of the cloud service provider, and they're focusing more on their application development, their development activity, their performance scalability, those kind of things. So that's cloud for you. I hope so. We're going to start from that level. I'm just stressing this point that we're going to start from very scratch. The way we just covered one introduction part, we're going to cover similar kind of thing, activities for each and every topic. Why do we need? What is cloud computing? Service models. How do we leverage infrastructure as a service, platform as a service, software as a service? What is the difference? Okay, what is the difference? First of all, we'll understand the deployment models. We're going to talk about a lot of AWS services. We're going to first understand about core cloud concepts, AWS regions. What do we mean by regions? So these are the regions, and what is availability zones? We're going to talk about that. What is IAM service? So we're going to talk about a lot of services. Okay, and that's all about learning cloud. We learn the services. When AWS launched in 2008, they came up with three services, just three services. It was the EC2, the S3, the storage services, and an SQS, simple queue service. Just three services. Back in 2008 when they launched first. They were the first one to launch this. Look at the service list now. Look at the service list now. They have more than 250 services, and the list is growing. and everything is automation. Everything, if you look at here, they are services for machine learning as well, for the game development. So you can apply this cloud anywhere. So learning cloud is a must for anyone who is in IT or non-IT, whatever, anyone. So that's the basic requirement now. If you do not know cloud, it's very difficult to be in IT because everyone is using cloud, and you need to understand one cloud service provider well. That's the need of the requirement, and I hope everyone knows that. For the database, earlier we just talked about RDS, relational database, right? But look at, because the way the world is changing, we have a different data model, different requirement. Dynamic data is coming. So the RDS, the relational database, the traditional way of how we store data is not enough. It's not that it's required. RDS is required. It's not required. RDS means MySQL, Oracle, MariaDB, PostGRE, Microsoft SQL Server. I'm talking about those things. RDS. There are other databases as well, which are like document database, we call it Mongo database, right? Where the schemas are different, the records are different. So there are a lot of other requirements. So you can, if you look at the database, also you have many options. So what I'm telling you, that this is going to be growing. This is not going to be just limited to only this. They started with these three services. EC2 was one of them. S3, this is the storage service. So I'm going to talk about that. S3, and one was SQS. You can find this somewhere. Okay. So they came up with just three service. That's just the three service. SQS here, simple queue service. They just came up with these three services when they launched, but look at them now. So, and it will be growing. And if AWS is coming with some service today, Azure comes in a week's time or in a 1 month's time, and same thing for GCP, because they are in the competition. They have to, if they have to compete, they have to grow, challenge themselves. So it's an ever-growing field in cloud. Cloud engineer itself is a good skill to have. Being a cloud architect, okay, that's why people are switching their career as well. If they get so much fascinated in learning cloud, they become solution architect. Uh, they have DevOps architect. There are different people, and the performance engineering, for performance engineering in general, you need to know each and everything, right? Then only you can understand the architecture better, and at the application level also you need to understand and then troubleshoot. For everything you need to know how things are implemented, right? So in any way you need to know all these things. Okay. So we're going to talk about each and everything in the cloud. So that's cloud computing, and there are a lot of services I just mentioned. I'm going to cover these services slowly. I'm not just going to bombard you with all the services list name and be overwhelming to you. So we're going to cover each and everything very slowly in a sequential manner, in a very structured manner. You would understand each and everything. Okay. So that's cloud computing. After that, Linux command line this is the most important thing, because I have included this as part of this topic, because when the idea is to get comfortable with microservices, Docker, and Kubernetes, right? And when I started to go about that, there were people who were not comfortable with Linux. There are people, if I just open one EC2 instance, and if I ask them to perform some activity, if I give them a file, if I give them a Linux console, and if they have a file, and if I ask them, can you find a word for me? Okay, no, the answer was like, most of the people do not know how to find a word in a Linux file. It's a Linux instance. I'm going to start this. So how to find a word in Linux, or how can you zip it? They're very much comfortable in Windows. They can do a Control F, find a word. They can do a right click. They can have 7-zip software. They can zip it. If I ask them, can you do the same thing in Linux? The answer was no. They are the very simple use cases. Okay, very simple use cases I'm talking about here. If you do not know such a basic things, it will be very difficult for you to work in microservices world and Docker, Kubernetes, because we deploy containers, we deploy Kubernetes, we create containers in Linux operating system. That's the reality. People do not do that in IT, in real world, in Windows operating system. We do it in the Linux operating system. So that's the requirement. And if I just ask them how to you calculate disk or how do you copy one file another, how do you rename a file? So the basic operations, I'm going to talk about it. And eventually, the shell scripting is the skill that you have. Shell scripting, which is used for the automation. If you have a lot of mundane tasks, right? Same repeating task, you would like to shell script that so that you can save time. So we're going to talk about shell scripting as well. The performance monitoring, the Linux performance. How do you what all you capture in Linux operating system? Yeah, and if I ask you what's load average, how many of you know that? Load average is a very important concept, right? And you can see that in the in so many options in places. If you look at, I'm going to go inside this VM. Okay, let me just start this. You can just think about it, load average. So it's a very important concept. If you just log into this guy, and you can see it in the many places. Okay, you have in the uh, top command, you can find in the uptime. If I ask you how long your system was up, your server was up, very basic command, and interviewer can ask you this simple question: how would you find the time your system was up, for how long your system was up? If I ask you simple question like this, let me just make it better. Just I'm gonna just make it visible so that everyone can see this clearly. Okay, I hope everyone can see this. So if I just ask you, how do you become a root user? Simple. How do you become a root user? Okay, so simple commands. Okay, if people do not know, they would not know. It's very difficult for them to give an answer, but it's a very simple thing once you know it. Okay, and if I ask you, how do you find how long your system was up? It's a very simple command you need to know. That's what 2 minutes, because I just started the server, right? I just started the server. What's this load average? What does this mean, load average? And if I just give you a top command, you also get the top load average here, but you just not get the load average, but you get CPU, memory details, and all the process level information. Okay. If I ask you, like if you must be doing a thread dump analysis, let's say, and if I ask you that if a particular process, how many threads are there in that particular process? How would you let me know? Because that's an important concept. Whether you're running a Java application, you can see that Java application in JVisual VM or any commercial tools, Dynatrace, AppDynamics. You can see that. But at the Linux, at the operating system level, there is a process running for that, like Java process running, with the process ID. You have a process ID, right? Because everything starts from the operating system, right? So if I just give you a process ID, let's say ps-ef, if I just ask you what is the Java application, so you can just do this, things like that, and you can find what's the Java process running, if it's actually running, and by taking one of the process ID, you can find how many threads are running. So very simple stuff. And if I ask you how much disk you have left in this box, I know it's 8 gig when I provisioned it. So this is the disk usage. If I ask you how much GPU you have, they are very simple commands. Okay. If I ask if I have a file, you find a word in a file. if I have 10 files, if I want to replace a word in a file, in all those 10 files all at once, how would you do that? You are very much comfortable working in Windows, but you are not with, most of the people are not with Linux. And that is why to cater that need, that requirement, I have considered this topic, and we're gonna cover this. Okay. So shell scripting as well. Very much required for this Linux performance monitoring. You need to know these commands. I'm going to talk about this as well. Okay, and this is very much required for your microservices, for Docker, for Kubernetes. Again, Kubernetes, coming to the Kubernetes, Docker it itself is a very important and demanding topic. Everyone asks you, have you worked on containerized environment? Have you got this interview question? You can ask yourself if you have been attending interview, you would know that they would ask this question: have you worked on containerized environment? How do you create containers? What is Docker? Okay, and what is Docker Compose? How do you capture the footprint, the resource utilization of the Docker containers? How do you work? How do you see logs? If you have Docker containers, basically you have your application deployed in a container, how would you troubleshoot it? How would you go about looking at the logs? How would you know what is the problem? Where is the problem? So you need to debug, go into the logs and understand things like that, right? If I tell you, can you assign a CPU or a memory to a particular container? In this operating system, I have only one vCPU. I can provide 50% of the CPU to one container. I can allocate that. I have 1 GB RAM here, 1 gig RAM. Okay. Can allocate 500, 400 MB of RAM to a particular container. I can do that. So we're going to talk about Docker Compose, because we're going to learn about this topic, Kubernetes. That's the most important topic. Everyone, performance engineers, DevOps, developer, SRE engineers, whoever you have to know Kubernetes. That's the fact. And people are struggling with Kubernetes because it's not that difficult, but yeah, it's a very vast. Kubernetes is a very vast, and you need a basic understanding. So we will start from very scratch, and we're gonna cover this Kubernetes. What is Kubernetes, and what's the AWS services, relevant AWS services? How AWS has implemented. We're gonna talk everything relevant to related to AWS, and you're gonna compare that with other cloud service provider. What is pod? You must be hearing pod. What is pod? What is the deployment, replica sets, the services, load balancer, node port? How do you auto scale the Kubernetes cluster? Because you have deployed the number of pods, but what if the additional users, more 100 users came in? What will happen? Will it be able to handle the load on its own, or you have to do it something manually? If you do have to do it manually, it's not worth, right? In production, will you be doing everything manually by sitting looking at the CPU utilization? No, you have to do it in an automated fashion. Everything is automation. So we're gonna do horizontal pod autoscaler. How do we do cluster autoscaler? How do we monitor the containers? That's the very important thing. CloudWatch Container Insights. It also scrapes Prometheus and Grafana data, Prometheus statistics as well. So we're going to talk each and everything about that. And at last, we're going to talk about DevOps. That's the most important part, because everyone, either you are a developer or a DBA or a performance tester or an automation engineer or security engineer or penetration engineer in your organization, or a UAT, whatever, wherever you are, you have to be a part of DevOps, because DevOps is at the organization level. And the main focus, the main goal of DevOps is to streamline the process so that the software deployment and release could be swift. That's the main objective. Once the developer completes writing its code, updating its code, doing a bug fix or any change request, once the developer is done, I need my code to be deployed in production as soon as possible with all the quality checks in place, with all the quality check validations in place. I don't want to compromise anywhere. I don't want to skip any of the activity, but I need my code to be deployed in production as soon as possible. That's the core goal of an of DevOps. Right? It's like, that's the methodology approach. That's the goal. Waterfall, we had issues. Agile, we had issues. We're trying to solve an issue of the agile, right? And through automation. That's what we are doing. And we're going to understand how DevOps work and how performance engineering fits in DevOps and things like that. We're going to cover. And how, as a performance tester engineer, you could contribute, you can contribute, how it integrates with GitHub, how it integrates with Docker Hub. We're going to talk about Jenkins. Jenkins is a CI tool. The most popular continuous integration tool is Jenkins. We're going to talk about that. Take up this DevOps topic through Jenkins. We're going to cover each and everything. I hope everyone got this opportunity to go over this link. It's going to be 40 to 45 hours. I hope you can understand this. Yes, it's going to be that much. So if anyone has not got this link, I'm going to paste this link in the chat window. You can go over this link and you can come up with any questions. So that's what I wanted to cover today from the course syllabus. I'm going to start with our day one, which is cloud computing, and which is our the introduction. So, do we have any questions before I start our day one course topic? Do we have any questions or clarifications? Open. Or anything, any feedback, anything you would like to speak. I'm going to give 5 minutes to discuss on that, and then I'm going to start with this. Yeah, looks like we are all good. You guys are following everything. Are we on the same page? Are we following everything? Do you feeling so? How can I get a quick acknowledgement? Yes, no. Quick,
Yes,
just keep right. Yeah. Okay. Good to know.
Yes, we are good.
Yeah. Good. Yeah. Thank you, everyone. I'm going to start with our day one. Okay. So this is the formal start of our course journey. That's the first topic that we take, cloud computing. And first slide, I have just listed all the topics that we're going to cover. Same thing of that link, whatever I have given, same information. I'm going to cover each and everything. Let's start with the main thing, the first thing, introduction. Okay. So, okay. Before the introduction, if you have, I was talking about that in the beginning, what is cloud computing? Before that, before I go into cloud computing and the introduction, I would like you to know that this is how the data center looks. Data center. When I talk about setting up a data center, basically I'm talking about this. Land acquisition is there, the building, the infrastructure, the cooling mechanism. There are a lot of cooling mechanism because, and these are the servers which are hosted in this data center, and it generates a lot of heat. You need a cooling mechanism. Basically, to sum it up, I'm just saying it's a very costly affair. That's what I'm telling you. That's the take-home message from this slide. That's the very costly affair. Setting up a data center is not that simple. It's a very costly affair thing. It's a very so I hope you can understand why it is so costly. And that is the main reason why not every company, not everyone who has some idea of creating an application. Earlier, back in 1980s, if you have some idea, and IT was just starting, if you have some idea to create some application, you have to set up your own data center. That was the situation. You can understand the problem there. If you do not have money, even if you have idea, you cannot go ahead and with your application development and cannot deploy it. That was the case when the IT started. But now if I have a small idea as well, if I want to open my own Swiggy or my Jmeter or my Ola, Uber, whatever the smallest of the ideas, whatever, Flipkart, a smaller version of Flipkart, I do not need to think about setting up my own data center. I can just go to any cloud service provider, AWS, Azure, GCP, Alibaba, Oracle, IBM, Salesforce, anyone, depending on the cost. I can take create servers there. I can deploy my application there, and I can get my application up and running in just few hours or few weeks. Uh, that's the simplest thing it can get, and it's a very costly affair setting up a data center. And that is why this cloud computing is in picture, because not everyone can afford to set up their data center. It's the same thing. Cloud, the word means, don't get confused with this word. The infrastructure which you do not own is the cloud. That's simple. And you are using everything on the rent basis. You're paying some amount for the servers that you're going to consume, for the operating system that you're going to consume, and for the storage that you're going to consume. You're going to just pay for that services. That's cloud for you. And this is how this traditional approach IT worked. If you are setting up your own data center, you have to have your own data centers, networking, storage, servers, virtualization, operating system, databases, security app. You have to have each and everything. It's a very costly affair. Okay, and that is why, and that's the legacy IT looks like. But now what happens? You just I just they I am just using everything, each and everything through a console. You see the AWS management console. They have everything, and they have given this option. They have given this console, that through this console being remotely located also, I can provision, I can create servers in any part of the world, wherever they have the data centers. In any part of the world, I can go and create servers. I can create servers in US. I can go to the US East one region. I can create EC2 instance there. If my customer base, let's say, is in US, I would like to have my servers in US, right? Because if I create my servers in Australia or New Zealand, there will be unnecessarily latency, right? If I know that my customer is base, most of the customer base, 90%, 80% of the customer base are going to be in US, why would I create a server in Australia or in Mumbai, right? Or in Europe? I would not do that, right? Or in the Middle East, I would not do that. I would choose a server. I would deploy my application nearby to my customer so that they get the best of the experience. They don't have this latency issue. So in that way, think in that perspective now. Think about application development now. And it's very important for a performance engineer to think about these things, because if your server is located far off from you, you are creating unnecessarily latency problem. Unnecessary. Then you have to talk about cloud front, edge locations. We'll talk about that. But as simple as that, if my server is located nearby, I can get a faster response. I can get my page would load quickly. So before cloud computing scenario, customers owning all the hardware and other components in their data centers, right, to run applications or programs. That was the case. Cloud computing allows people access to the same kind of application through the internet. That's what it is. I'm going to access each and everything through the internet. That's all I need. AWS account and the internet. That's all I need on laptop. That's all I need. and I can do anything. I don't need to think about creating my data center, my own infrastructure. I can just create anything. Why cloud computing? Obviously, efficiency and cost reduction, without doubt. Scalability, yes. You can have as many servers you would require as per the need basis. There are features like auto scaling. You can scale up your server, scale out or scale in based on some condition. Uh, you can have any scalability. There is no limit that how many you can use, only this many servers. Nothing like that. You can use as many servers you would need, and you just need to pay for that. That's simple as that. It can be scaled. Scalability is not an issue at all. Disaster recovery, even on-prem customers, they have their data center also on-prem. They are using cloud for their disaster recovery as a backup. As a backup, they are using cloud. At least they would have data storage, because they understand they don't want to create another data center for disaster recovery. They are using cloud as a the disaster recovery. Though they have their own data center as well. Nowadays, this hybrid cloud model is into the fashion. Everyone is doing cloud. Let's say if I'm an investment company, investment banking company, and for me, the data is very important. I cannot I cannot take a risk with the data. What I can do, I can afford to have my own data center. What I can do, I can have my databases, my data in my on-prem, and my application servers, my web servers could be in the cloud. So that's the hybrid cloud we are talking about, hybrid infrastructure, where you are dealing with multiple cloud service providers, uh, on-prem or as well as AWS. And same thing, you have people also do it. They have their one server in Azure and another server in AWS, so that they don't have a dependency on one cloud service provider. Multi-cloud, hybrid cloud is the trend. And either it could be on-prem or one cloud service provider or two cloud service provider. Data security, that's the best way. The cloud is secure, and there are so many ways to secure your data. Uh, they are all the characteristics, the features of cloud. Okay. You get the best of mobility, the control. You don't have to worry about automatic software updates, updating your software. The cloud service provider can do that for you if you're using elastic services. We're going to understand what is elastic services. So that's in short, that's the introduction of cloud computing, and that's how it goes. Okay. If you look at the definition, what is cloud computing? The simplest of definition: cloud computing is computing based on the internet. Yes. Cloud computing is a term used to describe the use of hardware and software delivered via network. That's all is happening, right? We are getting the hardware as well as the software delivered via network. That's all is happening. Going to create hardware only, right? When I say I'm going to create EC2 instance, basically I'm creating a hardware through the internet. I'm getting the hardware access through the internet. Everything is, so that's what I'm talking about here. And these are the definition part of it. Using virtualization. So you need to understand what does virtualization mean. When I say virtualization, there was a topic. Virtualization means, again, back in 1980s, if you remember one of the slides which I went over yesterday, I talked about there used to be physical servers back in 1980s, and even if people needed to deploy one tiny little application, they would use the complete physical server to deploy one simple application. They would waste a lot of resources is goes unutilized, right? And this virtualization came into picture, and then we were able to create VMs, right? And that's what I'm just showing here. That's the physical server, and I'm installing one hypervisor software here, one virtualization software. hypervisor, and I'm creating VMs. And that's all we are doing. When we are creating an instance here, when we're creating a VM here, the virtualization has already been done. The virtualization has already been done by AWS, and I'm going to create VMs. When I say launch instance, I'm going to create one VM here. So Peter has a question. So we are accessing hardware or OS, memory, disk, wide from physical hardware, which is real. Peter, can you elaborate your question? What you meant? Hello, you there, Peter? Peter, you're right. That's what we are doing, right? We are accessing everything: hardware, memory, disk via internet. That's all we are doing, right? And it's real hardware we are talking about. We are going to create hardware. We are going to create instances in any region you would specify. That's all we're gonna do. That's cloud for you. That's the cloud. And that's what cloud enables you, right? Can I get an acknowledgement, Peter, from you that you have understood this part? Yes, no? I'm not sure. You're not audible. I cannot hear you, Peter. So you need to unmute and speak if you have question. Okay. But yes, but to answer your question, yes, this is what existing hardware from Virginia via cloud. Yeah, you can do that, right? That's what we are doing. You can speak, Peter. I'm fine with that. You can speak, right? Yeah. Okay. That's what we are doing, right? That's what we are doing, Peter, right? We can select any region which is listed here. So AWS has data centers there, and you can provision, you can create any server there. That's what I'm talking about. That's cloud for you.
Roshan, is there any limitation of creating the EC2 instances, or we can create a number of
Nothing.
EC2 instances?
Any number, any capacity. If you look
Mhm.
at launch instance, if I just show you, if I just select any operating system, let's say I'm selecting. Let me just do this. Just go to my region where I was EU Central 1. There is no such limitation. Why? They are. It's. You're asking this question. If I go to a shop, is there any limitation of how many items I can buy? You're asking this question. I hope you understood, Vibha, right?
Yeah, got it. Yeah.
Right.
Thanks.
So there is no such limitation of how many items you can buy, right? You can go to a shop, you can buy your complete shop. That's up to you. So you are asking this question. You are already, they are giving this cloud service, they are giving this hardware, the access. They have set up their data centers for you to rent. In the shop, you have items for you to purchase, right? Why would they put a limit? As simple as that. So you can
So,
select any operating system. Yeah.
sorry. So basically, every time we create an instance, a particular memory or particular space is allocated in that AWS machine, AWS for us. I mean, if we actually
Yes.
create an
Yes.
instance in, for example, we are talking about Frankfurt.
Yeah.
If we create an instance, so every allocated space is do we have that
Yes, you're
or
right. Yes, you are in the data center. You are going to assign a dedicated hardware. You're going to assign. See, I selected the operating system. If you noticed, you have the option of selecting the operating system. What operating system you would like to have? Either you go with Red Hat or Windows, whatever you have all the options, or you have Ubuntu. You have so many options. So let's say I went with Red Hat. Now in the next screen, I have the option of how many vCPU you would require. I can go till 48 vCPU, 128 vCPUs max, but we don't need to use that much, that large. I can select T2.x large or T2.micro, one CPU, because it's a free tier eligible. I'm going to select this more. But because this if I select this more, just to demonstrate, it's going to be costing. So I can have 8 vCPU, and with that 32 GB RAM is coming. So basically, you are creating a VM. I hope you have worked with VM, right? You have worked with a VM, application server, web server, database server, right? You
Right.
work with a VM. So you are basically creating a VM here. VM of your own, operating system of your own choice, the number of vCPU of your own requirement, and the RAM of your own requirement. And next stage would be the disk. How much disk you would require. So add storage. You can have your disk also. You can specify that you need 100 GB or 500 gig, or you can max put. There is no such limitation of this use. You can have any number of the gig. So you can specify that, and in that Frankfurt region, in Frankfurt region there are 3 data centers. Okay. Again, I'm going to talk about that, but in every region, they have multiple AZ concept, availability zones. In one region, they don't have one data center for high availability. What if one of the data centers goes down for any region? Flood came, natural calamity happened, something happened. They would not have just one data center in one region. They have multiple data centers. So that, and as a customer, I'm going to deploy my application, my servers in multiple data centers, so that if one data center goes down, I have servers in other data center to handle my request, to take care of my request. So at end of it, my goal is that my application should not go down. High availability, the reliability is my goal to achieve, right? That's what we're gonna take care of. That how can we make sure my application is highly available? If my application is available in multiple data center, and even if one of the data centers goes down for any region, I have other data center and my server is hosted there as well. My request can be rerouted to that server. I'll set up a load balancer as well, so that it can reroute my traffic to the healthy data center. I hope you're understanding the basic part of it, right? Yeah. Yes. No.
Yes.
Yes, sir. Yes.
Yes,
Yeah.
yes.
Right. So you're gonna create server, basically real server, and you can access it. I was just accessing it, right? One of the server, I just accessed it. It's your server. It's your server. I just accessed my server here. Something. Let me just. This is your server. You can do anything. You can install any application. You can install web server, database server, app server. It's your server. Like the way you have your own VM, you use your VM, right? So same thing I'm talking about here. Okay, that's the concept. That's the introduction of the cloud. I want you to realize this part first. That's how things work in cloud. First, appreciate this knowledge, that this technology or this particular thing, cloud. What is cloud for you? That's the cloud for you. That's the simplest definition. Cloud computing is a term used to describe the use of hardware and the software delivered via network. I can provision anything, anywhere. Not talking about the server, I can talk about S3 storage. I can have that also. Like you have, just to relate S3, you have Google Drive, right? In Google Drive, you have a limitation, 5 gig. In S3, there is no limitation. Your Netflix, okay, let me make this interesting. your Netflix, your Amazon Prime videos, those so many media files, so many videos, so many movies, serials, so many media objects, I would say, where they are stored, the entire Netflix is hosted in AWS. And needless to say, where would be Amazon Prime videos hosted? Amazon Prime videos from the same family. Entire Netflix is hosted in S3. Your entire movie list that you see here. They are not owning, they don't have a data center. Netflix doesn't have a data center. They are using AWS.
Roshan,
I
you
hope.
spoke about the hybrid model, right? So, is it the physical option since we already have the on-prem servers and migrating it to, so hybrid model is the most feasible one?
The mostly used one, see, even if you have on-prem, if you are working in a company, they afford to have their data center. Okay, let's say that. But there are so many companies, they cannot afford to have their own data center. What they would do, right? And hybrid is the culture. Even if you're working in on-prem, if you have your data center, to back up everything, you need another data center. Is your company ready to invest so much again for another data center which you use for a backup, or they are thinking about a cloud option? It's all about decision. Cloud is giving you the option of using as a disaster recovery. So, and obviously, and there are so many companies I know that they are not hosting their databases on the cloud. They will have their on-prem, like like your investment banking firms. They have their databases on-prem, but the other servers are in cloud because they can auto scale. Flexibility is not an issue, and the customer base is increasing. They have two options: either they need to again set up one data center, purchase the hardware, purchase the software, everything they need to set up again, cooling mechanism, so much investment in setting up a data center. Why not they would use the data center for hosting just the database server, but other server could be in the other cloud. And they would have all the networking in place. We'll talk about VPC. Once we talk about VPC, you'll understand how two networks connect. It's a feasible option. That's the trend we are in. I hope I answered your
Okay,
question.
thanks. Yes, thanks, Roshan.
People are preferring this and stuff. Peter, it's up to the people who are preferring it. But if you going by the stats, you can just look at the stats, cloud market share. You would understand about the people. Okay, you can just look at the stats, any stat, and you would know which one people is asking for more. So 33% is AWS, you would find. Okay, it would be there in one of my slides. Let me just show you quickly. I don't want to go over the internet, but this is the I have this information. So if you look at AWS, 33%, 1/3 of the market is being captured by AWS. 20% is Azure. I told you, it's not like there are less people. But if you know one, you have to start from somewhere, Peter. So start with AWS, or you can start with Azure. It's up to your call. If you think Azure, that's fine. But that's the data in front of you. Okay, that's all I wanted to cover today. We're already 6 minutes ahead. Okay, so we're gonna continue our discussion, and we are in this why cloud computing, what is cloud computing in that part only. We're gonna continue our discussion from tomorrow. Thank you everyone for joining. We'll connect tomorrow. Thank you.
Thank you. Have a good day,
Thank
everyone.
you. Bye.
Thank you, sir.